Good evening, my YouTube viewers. It's Crystal here. I'm just here this evening because I wanted to do another code review for you. And I'm still using the mini dog and cats data set. And the reason why is because it's a very small data set. And because it's a very small data set that it'll run through the program quickly, because if you have a large data set, then it's going to take a long time to run through the program. But you can use this code on other data sets. You don't have to use it just on the mini dog and cats data set. You can use it on the other data sets. And so what I'm going to do is I'm going to use a numpy neural network. And I got the code from ChatGPT, but I had to modify it. So it didn't just automatically work. It had to be modified before I could get it to work. So I'm going to go ahead and do the code review for you so you can learn how to do a neural network in NumPy. So we use the mini dog and cats data set, which you can get on Kaggle, and I ran the program up in a Kaggle Jupyter notebook, and it's saved in my Kaggle account. But what I will do is I will leave a link to the Jupyter notebook in the description box down below, so you can look at the code. So we're going to look at the problem statement. Problem statement is classify dog and cat images, which means it's binary. And these are some of the libraries that I used. I didn't use all of the libraries, such as I didn't use sklearn in this particular data set. So we use NumPy, which creates NumPy arrays and also performs numerical computations. We use pandas to create data frames and to create the data frames and to process data. We use random as a random number generator. We use PIL, which does image processing. From PathLab, we use PathLab, which helped us with our files. We use CV2, which does image processing. We use OS, which goes into the operating system. We use Globe, which helps us with our files. We use imported Shuttil, which helps us with our files. We didn't use sklearn in this occasion. We used matplotlib.pyplot, which visualized the data, and we didn't use Seaborn on this occasion. So after we've imported the libraries that we want to use, what we've done is we use OS to retrieve the files. And we have retrieved 20 JPG files. 10 of them are cat images and 10 of them are dog images. So this is a really small data set, and because it's such a small data set, it enables you to run through the code very quickly. So, but if you want to use a larger data set, then feel free to use a larger data set. I just wanted something because obviously I was experimenting, and because I was experimenting, I didn't want to take a long time to turn through the code. So that's why I used such a small data set. Then what we want to do is we want to visualize the images. So we have one dog image and one cat image, and so you can see that. And this is the code that I got from ChatGPT, but I had to modify the code. So the first thing we're going to do is we're going to define the function load and pre-process images. So image data is a blank array, image labels is a blank array. For file name in os.listdir file path, if file name ends with JPG or file name ends with PNG, img equals cv2.imread os.path join folder path file name, img equals cv2 resize IMG 6464. So it resized it. And then now we're going to normalize it. IMG equals IMG dot AS type float 32 255 over 255. So you're going to divide all of the cells in the image by 255 to make all of the cells to be a value of between 0 and 1. Now we're going to flatten the image to make a 1D array. IMFlat equals IMG.flatten. And we're going to append the flattened image to the data. ImAgeData.append IMGFlat. And now we're going to append the label to the labels list. ImageLabels.append label. So we're going to return np.array image data and np.array image labels. And so now we're going to work on it. So cats folder is Kaggle input mini dogs and cats dataset cat. Dogs folder is Kaggle input mini dogs and cats dataset dog. We're going to load and pre-process the cat images. Cat data, cat labels equals load and pre-process images. Cats folder label equals 0. And then we print the shape as well. And then dog data, dog labels equals load and pre-process images. Dogs folder label equals 1, and we print the shape of that. So we concatenate the cat and the dog data. X equals np.bstack, cat data, dog data. Y equals np.concatenate, cat labels, dog labels. So we're going to shuffle the data. Indices equals np.arrange x.shape 0, np.shuffle indices. Now we're going to define the x and the y variables. X equals x indices, y equals y indices. And then we have to reshape y. And because if you don't reshape y, it won't work. So y equals y dot reshape negative 1, 1. So now we're going to split the data into training and testing sets. Split ratio equals 0.8. Split index equals int. Split ratio times x shape 0. X train x test equals x to colon split index x colon split index colon, and y train y test equals y colon split index and y split index colon. And then we're going to print that because it's always important to know what the shapes are, because one of the things that happened was whenever I first ran the program up, it didn't work. And the reason why it didn't work is because I had to reshape my y variable. So it's always a good idea to print out your shapes. So if your shapes are correct, it's a pretty good indication that what you're doing is correct. So now we have the shuffle, but we didn't use it. I didn't use the shuffle, but it's there anyway. Now we're going to look at the logistic regression. So input size equals x dot shape 1, hidden size equals 128, output size equals 1, learning rate equals 0.001, epochs equals 1000. And then now we initialize weights and biases. Weights input hidden equals np.random rand_n, input size hidden size. Biases hidden equals np.zeros 1 hidden size. Weights hidden output equals np.random rand_n hidden size output size. Bias output equals np.zeros 1 output size. So now we define our sigmoid function, which is 1 over 1 plus np.exp negative x. And we defined our sigmoid derivative, which goes along with the sigmoid function, and it returns x times 1 minus x. So now we're going to train the neural network for epoch and range epochs. hidden input equals np dot dot x train weights input hidden plus biases hidden input equals sigmoid hidden input output equals np dot dot hidden output weights hidden output plus biases output predicted output equals sigmoid output input. Now we compute the loss. Loss equals y train minus predicted output. And we check our back propagation. Output error equals loss times sigmoid derivative predicted output. Hidden layer error equals output error dot dot weights hidden output dot t, which is transformed, times sigmoid derivative hidden output. We're going to update our weights and biases. Weights hidden output equals weights hidden output plus hidden output dot t dot dot output error times learning rate. So biases output equals biases output times plus np dot sum output error comma axis equals 0 keep dims equals true times learning rate. Weights input hidden equals weights input hidden plus x train dot t dot hidden layer error times learning rate. And biases hidden equals biases hidden plus np dot sum hidden layer error axis equals 0 keep dims equals true learning rate. So now what we're going to do is we're going to predict on the validation set or the test set. So we're going to test the trained model. Hidden input test equals np dot dot x test weights input hidden plus biases hidden. Hidden output test equals sigmoid hidden input test. Output input test equals np dot dot hidden output test weights hidden input plus biases output. Predicted output test equals sigmoid output input test. And we're going to convert the predicted probabilities to binary predictions of 0 or 1. Predictions equals predicted output test greater than 0.5 S-type int. And then you're going to evaluate the accuracy. Accuracy equals np dot mean. Predictions equals y-test. And then you're going to print the accuracy times 100. So you have an accuracy of 75%. So you've got a 75% accuracy on this one. Now, if you use a larger data set, then there's the possibility that you'll get better accuracy, but since we used a small data set, we only had 4 images in the test data, then, it was hard to get a really good accuracy. But you've got the code now. You can use a bigger data set if you want to practice on. And now you know how to do a neural network in NumPy. And I did get the code from ChatGPT, but I did have to modify it. I wasn't able to just use the code. I had to modify the code before I could use it. So I'm going to go ahead and conclude this video because I've done the code review for you. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my video. I look forward to making more videos for you in the future.